There are things in the world that are made to last for a lifetime, and there are things made to last far longer than any lifetime can measure. Small, faithful machines given a single, improbable assignment to carry a piece of us into a place where no sun will warm their metal again. Voyager 1 is one of those things. Launched in the autumn of 1977 from Cape Canaveral atop a Titan rocket, it was conceived as an elegant, practical answer to a particular opportunity, a rare alignment of the outer planets. But it left behind the reasonable bounds of its mission and became something else. A patient messenger, moving outward in straight, silent obedience to gravity, sending back whispers from a place humanity had never touched. On the pad that day, the launch felt, to a watching world, like a bright punctuation mark. The roar and combustion, the column of light and smoke, the human faces turned upward in hope. All of that belongs to a particular time and place. What survives of that moment is quieter. The ship itself, about the size of a small car, folding its solar sails of technology and beginning to coast beneath the indifferent dome of space. Its instruments were built to see and measure a universe we only then barely knew. Cameras, particle detectors, magnetometers, a radio antenna aimed like an eye toward home. Every part of Voyager was designed to tell us what lay beyond the next horizon. The probe's first act was practical, to use the gravity of Jupiter and then Saturn to fling itself outward on a trajectory no chemical rocket could have achieved alone. Engineers at JPL called it the Grand Tour, a small window in the heavens when the planets lined up in such a way that, with careful planning and a handful of well-timed slingshots, a single mission could visit them in sequence. The maneuvering was precise and patient. In the close quarters of those encounters, Voyager rewrote our picture of the outer solar system. Jupiter revealed itself with a voice and a fury that no one had expected. Voyager's cameras returned towering, roiling storms and atmospheric bands that moved like weather systems of unimaginable scale. It discovered that Jupiter's moon Io was an erupting world, a place where molten rock rose and sprayed into space, where volcanoes sent plumes hundreds of kilometers high. The gas giant's magnetosphere and faint rings, the complex interactions of charged particles, these were not distant abstractions but tangible, roaring phenomena that Voyager recorded and transmitted bit by bit across unimaginable space. Saturn, when Voyager came alongside, was not merely a planet with rings but an exquisite, intricate system, a study in geometry and fragility. The rings, once thought to be solid and static, showed themselves to be braided with structure. Gaps, waves, spokes, features shaped by islands of tiny moons and the invisible tug of physics. Voyager peered through the haze of Titan and measured a world wrapped in a dense nitrogen shroud, a moon with its own secret meteorology. Those flybys did more than expand our knowledge. They altered our expectations. The solar system was not a quiet clockwork. It was a wild, dynamic place, full of weather, chemistry, and motion that demanded new ways of thinking. And then, after completing its primary objectives, Voyager 1 did what it had not been originally designed to do. Instead of being returned to a museum or left to drift near its last encounter, it kept going. With its last planetary encounter, the probe was placed on a course out of the ecliptic plane and toward the edge of the bubble our sun projects into the galaxy. That bubble, the heliosphere, is an ocean of solar wind and magnetic fields that cocoons the planets and shapes a protective boundary against the steady rain of galactic cosmic rays. At some distance, the sun's influence thins. The solar wind slows and fades into the interstellar medium. Crossing that boundary, the heliopause, was not a guaranteed moment when Voyager 1 was built. Yet decades later, with instruments aging and power slowly dwindling, it gave us more than we dared expect. Voyager does not broadcast like a radio station. Its transmitters are small, more like the power of a household light bulb than a broadcast tower. and the signal that reaches Earth has to be collected by the Deep Space Network. Vast dishes spread across the planet that catch a few photons and turn them into meaning. For decades, engineers have listened to a narrow, steady carrier wave, extracting science from fluctuations in that thinnest of messages. In 2012, those fluctuations told a story. The signs of the solar wind grew faint. The count of high-energy cosmic rays went up as the sun's shielding slipped away. A later flare from the sun sent ripples that Voyager heard like a bell, and the frequency of the ringing told us the density of the surrounding plasma had increased, a sign, finally, that the probe had stepped beyond our heliosphere into interstellar space. The announcement that followed was not a triumphal fanfare, but a quiet recognition. Human-made technology had passed a threshold that no human had crossed. Aboard Voyager is something that feels less like technology and more like a gesture. A circular disc of copper, gold-plated, an analog phonograph designed to outlast the ways we typically record memory. It is the golden record compiled by a small, purposeful team who tried to distill a planet into a single object. Etched on its cover are simple diagrams intended to orient anyone who might one day find it. A pulsar map showing our place in relation to spinning neutron stars, a diagram of hydrogen's transition to mark a unit of time. Under that cover lie 116 images, sounds of nature and the city, greetings in 55 languages, the crackle of a thunderstorm, a mother's laughter, a child's cry, and a 90-minute montage of music that ranges from simple percussion to complex symphonies. There is Bach and a Peruvian wedding song and the electric guitar of a 20th century American hit. The record is not an instruction manual. It is an invitation. It is meant less as a how-to than as a who we are. The record is also a paradox. It is absurdly human and wildly impractical. The chances that any extraterrestrial intelligence will find Voyager and be able to read the record are vanishingly small. In the time it will take Voyager to drift to the nearest star, tens of thousands of years, then countless millennia beyond, civilizations will have risen and fallen on Earth. Yet the fact that we made such an object at all is what gives it meaning. It is a physical act of hope, a belief that the universe might one day encounter a trace of us, and that, should that day arrive, we might be understood or at least heard. Time for Voyager is an accumulation of small ends. Its power source, a radioisotope thermoelectric generator warmed by the decay of plutonium, produces a slowly diminishing supply of electricity. Each year, engineers make choices, turning off heaters and instruments to conserve the pulse of power that allows the probe to keep speaking. The voice gets quieter, the data rate drops. Yet in the midst of that decline, the probe has remained useful. Even as systems are mothballed, others continue to take measurements that cannot be made from here on Earth. Voyager's magnetometer listens to the magnetic tides. Its cosmic ray detector counts the invisible rain of particles. Its plasma wave instrument, when it can, converts subtle electric oscillations into language. The data arrive hours later, parsed by teams who have learned to translate the faintest of signals into revelations about the space between the stars. There is an archaeology of hardware in Voyager's slow retreat into the void. A camera long cold, a tape recorder that stopped turning years ago, circuitry that still answers the call from a home it was never meant to outlive. The story of Voyager is as much about human determination as it is about engineering. It is about people who, in the face of dwindling power and the creeping obsolescence of decades-old electronics, decide to keep listening. They reprogram, they calculate new ways to use old instruments. They find poetry in patience, a quiet thrill in keeping alive a conversation that began before most of their children were born. And there is a philosophical layer to this outward motion. Voyager is a record of curiosity and defiance. It embodies a species that woke up one morning, and instead of merely occupying its small planet, turned a careful eye outward and made a deliberate choice to reach. That decision is both humble and audacious. Humble because the craft carries our modest sounds and an analog record that needs manual decoding. Audacious because we felt, for reasons partly scientific and partly emotional, that our existence was worth broadcasting into the vast dark. What does it mean that Voyager will likely outlive the civilizations that launched it? The answer depends on what we mean by outlive. The machine will persist as a collection of atoms tracing a ballistic path around the galaxy, perhaps for millions of years, until chance alters its course or it collides with something else. Its record may never be read, yet its very persistence changes the frame through which we think of ourselves. For a brief human heartbeat, we threw a message into the ocean of space and trusted it to keep going when we could not. That act is a mirror held up to our species. We are both fragile and capable of gestures that reach beyond survival to speak to posterity. The image that perhaps best captures this paradox is a small, pale dot in an immense sea of black. In 1990, at the request of one man who wanted to remind us of our scale, Voyager turned its camera back toward home and recorded Earth as a speck against the glare of the sun. To call it a pale blue dot is not to diminish the miracle it holds. Rather, it is to place that miracle in perspective. Every national boundary, every triumph and failure, all the love and cruelty in ordinary days were contained in that sliver of light. Voyager took that image and kept moving. There is comfort in thinking of Voyager as a sentinel, a slow-moving testament to the fact that something on Earth once felt the need to know more. There is also a piercing loneliness to it. The knowledge that out there, in a darkness that is indifferent to intent, drifts a small object carrying a record of our music and our greetings. Perhaps someone, an intelligence not human, with senses we cannot imagine, will ever pick up that faint pattern and wonder who made it. Perhaps no one ever will. Either way, Voyager stands as a choice we made, to be more than a species defined by its survival, to be a story that reaches beyond the immediate and the certain. In the end, what Voyager teaches us is less about distant space than about time and attention. It asks us what we would send into the future if we could speak beyond our moment. It asks us to consider the shape of legacy in a universe that does not require it. And it reminds us with the hushed persistence of its signal that something of human curiosity has already set out, slow, stubborn, and hopeful, to keep our question alive long after any single life has ended. Somewhere beyond the planets, carried on a craft no larger than a car and no louder than a memory, a golden record spins, and the antenna still leans toward home. It will not return answers. It does not need to. It is already an answer, a small, patient testimony that once, in a corner of the galaxy, a species stood up, listened, and sent a voice outward into the night. Long after our names fade, it will keep whispering that we rose and looked outward and wanted, in our imperfect way, to be known.